Hi, ladies and gentlemen. This is Mr. Green, and I am at a testing site today. I know most of you are not involved in the testing, so I'm going to go ahead and record this Class Connect for you so that you can get it and will be able to watch it and be able to move forward from there. Now, I know it's something that I didn't really want to be missing with us taking up a new topic as a part of this lesson, but I think that you all can probably handle this. It's not going to be too big of a deal. We're going to be looking at hyperbolas and at parabolas. Now, you guys think, oh, we've already done parabolas. We'll talk about that in just a second, okay? So we'll get into that in just a little bit. Now, first of all, hyperbolas. When you look at a hyperbola, you look at the general equation for a hyperbola, it looks very similar to an ellipse, because you've got the x squared, or x minus h quantity squared divided by a squared, and you got the y minus k squared divided by b squared. The difference is the subtraction right there. That subtraction makes all the difference in the world, okay? Where an ellipse looks like this, kind of a circular type object, a hyperbola looks like this, more like parentheses. And so you've got to be careful with it, okay? Now, careful with ellipses too. I'm sorry, with ellipses, you could determine which one was bigger by looking at the bottom number, seeing whether it was the a squared was bigger or the b squared was bigger. And if it was the value underneath the y's were bigger, that meant it was a vertical ellipse. If the value underneath the x's was bigger, that meant it was a horizontal ellipse. You could look at it that way and get it very easily. For hyperbola, you have to look at which one is being subtracted. If the x's are being subtracted, then you're looking at a horizontal hyperbola. If the y's are being subtracted, you're looking at a vertical hyperbola. And you just have to know that there's a difference between those two. It doesn't matter which one you're talking about. The value subtracted from the x and the value subtracted from the y become the center, xy. Okay? There's an asymptote in a hyperbola because what you've got is a line that kind of runs through here like this, okay? Separating these two. It never touches those lines though, okay? Where these two lines intersect in the middle, that's the center that we're looking at. Okay, so what you can do is you can find these asymptotes and you can then take the center and the asymptotes here and you can wind up being able to draw the hyperbola very, very easily, or at least sketch it out for yourself, okay? Now, the asymptotes, you find it by going to k. Well, k is the value here being subtracted from the y. See it right there? Right there? It's really easy to find. And then you're going to go plus or minus a over b times x minus h. That will be your asymptote. It will be a line, okay? Real easy. It's not going to be anything other than it'll be a straight line. So let's look at a couple of these real quickly. So here's it's asking what type of a conic section do we have here? I want you to notice, see the minus sign here, see the squared, see the 1. That tells you that you have a hyperbola. Okay? Not a problem. We can deal with this. Where's my center? The center of this one is going to be at -2, 1. -2, well, there's the value that's subtracted from the x. You got to use the opposite sign there, -2. And there's the value subtracted from the y, 1. That's where my center is going to be located. Okay? So let's look and see where would we put the other things, like the asymptote. Well, the asymptote is going to be at 1, the value of y. We had that one, y, 1. Plus or minus 5 over 6. Well, that's this value here, divided by this number, right? 5 over 6 times x plus 2. Where'd the 2 come from? Well, the 2 is the value for the center here, right? So it becomes real easy for you to locate that. You can go to the point -2, 1. That's right there. And you can draw in those asymptotes, and then you can just kind of sketch what the hyperbola looks like. And this is a vertical one. How do I know it's vertical? Because the x's are the ones being subtracted. Okay? So, why did I calculate this 25 squared plus 36 squared equals 61? So c is equal to the square root of 61. Well, c is a value that you're going to use in the foci. The foci, you're going to say, well, I'm going to take the center and then plus this to find that focus point. It's going to be up in here. In here. Okay? That's the focus point. My vertices, they're going to be right here on this. So actually I'm going from here, going up just a little bit. And what you do is you take the x value, you take the y value plus the value that was underneath the y, the square root of that value, plus 5. It's really easy to find these vertices and these foci. It's not really an issue at all. Okay? Now, if you're looking at something like this and they're asking you to find the graph, well, you know what? One of the things I do is I come along here and I try to sketch out as best I can what would the asymptotes look like. And just by drawing some straight lines in here, I can see, it looks like my asymptotes intersect right here at 0, 0. So I'm thinking my center is at 0, 0. Okay? I can look at this and I can then find the slope of this asymptote here. Looks a little bit difficult to see here. Maybe I can't find that center quite as easily as I think. But I can look up here and I can say, well, you know what? There's a point right there and a point right there. And there's a thing called a directrix. It goes right through here. The value from this distance from here to here and this value to here to the directrix should always be in ratio to each other. So what you wind up getting is the C value by doing this, okay? And I'm kind of confusing here, but essentially I know that my center is at 0, 0. My asymptotic line after I figured out the slope on it was the square root of 2 over 2. And so what I wind up with is that A is going to be the square root of 2 and B is going to be 2. That's A over B, right? And so A squared is 2 and B squared is 4. And so this winds up being my equation right here. Okay? I think you do a couple of those, it might be a little bit easier for you to see them rather than me just kind of guessing about them. Okay? Let's go back to what we were talking about. Anytime we're talking about these conic sections, we're talking about two cones that have been put together. If you slice it parallel to the base, you're going to get a circle. You get it angled to the base, you're going to get an ellipse. If you slice up and down vertically, parallel to the center here, going up and down this way, or even at slight angles to the center, less than the slope of the cone here, you're going to get what's called a hyperbola. That's what we're looking at right here. I wanted to point this out because it's showing you really clearly what a parabola looks like. A parabola actually has a parallel side. The slice is parallel to the sides of the cone. That's why it's not hitting the other cone here. Okay? And the whole issue here is if it's parallel, it's going to make this parabola. If it's not parallel, it's probably going to make a hyperbola or an ellipse of one sort or another. That's very interesting. Okay? So one of the things we look at is what is the eccentricity of it? Eccentricity is basically the distance, the foci, divided by the distance to the vertice. And what you're looking at when you're doing that is, well, from the foci to the vertice. That's this distance here, from the foci to the vertice. Okay? And that type of a distance every time is different for these different types of values. For an ellipse, you're always looking at something that is almost always in the middle. Hyperbolas are always the smaller numbers and parabolas are always the bigger numbers. Okay? So what are you looking at there? For an ellipse, you're looking at that elasticity to be less than 5. And for a hyperbola, you're looking for it to be greater than 0.5. And for a parabola, it's almost always equal to 0.5. Okay? That's what you're looking at when you're looking at these different types of shapes. Okay? So we're looking at it a different way. A directrix is a line here. It has an eccentricity of infinity. Hyperbola sits here in the middle. It's got that eccentricity that's less than 1/2. Parabola is almost always at 1/2, and a ellipse has one that is greater than 1/2. What I said? Yes. The ellipse is less than 1/2, and the hyperbola is greater than 1/2. Okay? So what you're looking at here, here's the vertex, here's my focus, and you can see this one is less than half that distance. This one is about exactly half that distance, and this one here is greater than half that distance. Cool? Good. Okay, so when we look at this equation, what do we see? Well, my x and y's aren't being subtracted. I've only got one of them that's being squared. My y values aren't being squared. This is actually a parabola. A parabola. Okay? Now, should be very familiar to you because you're going to wind up with y equal to something x squared. Well, that's basically the quadratic formula that you're used to. This is going to be a vertical parabola, looking like that. Okay? Because and basically what you got to look at here is if the x terms are being squared, x minus h, remember this is going to be the vertex of it, right? The x value for the vertex. If it's the x value being squared, then you're talking about a vertical parabola. If I turned it around the other way and said y minus 4 squared is equal to 4 times x plus 1, now you're looking at a horizontal parabola. Ooh, blow your mind. You didn't know there was such a thing, did you? Well, yes, there is a vertical and a horizontal one. This one would have its vertex located at -1 comma 4. So -1 comma 4 be up here, and it would be going like this. You didn't know you could have vertical and horizontal parabolas, did you? This one is not a function. That's why you haven't studied that one before. Remember? Vertical lines, crosses it twice, not a function. Okay? So I want you to notice your axis of symmetry on the vertical one is at x equals 4. Where'd that 4 come from? Right here. Not this one over here. This one, the 4. That's where the axis of symmetry comes from. My vertex is at 4, -1, 4, -1, right? And so this one would look like that you go over 4 and up, down 1. It's going to look like this, like that, correct? My axis of symmetry goes right through there. Sorry, I had to cough. Okay? So you can tell the difference between these two. This one is a vertical one. This one is a horizontal one. Make sense? Okay. Now, if I give you this equation like this is the general form of it. You've got to try to put that into the format that you can graph it. Well, I'm going to take the y's and this y value and move it to the other side, and this 8 move it to the other side. So I'm subtracting them here, so I wind up with this. I get x squared minus 8x equals 8 minus 8y minus 8. What I'm looking to do is I want to complete the square here. So I'm looking for the value that I take this minus 8 divided by 2. I get minus 4 squared. I get 16. So I'm going to add 16 on this side. I got to add 16 over here so that minus 8 becomes a plus 8. Okay? Do you see where that 16 got added on there to give me that plus 8? Now that means that this side over here becomes x minus 4 squared. This side over here, I can factor out a minus 8. I get minus 8 times y minus 1. And then I can divide this 8 into that 4 times minus 2. And I've got my general form equation now. My center is going to be, or my vertex is going to be located at 4, 1. 4, 1. Okay. That's where the vertex is located at. This negative 2 tells me that it points down, doesn't it? The fact that the x squared is being, or it points in the opposite direction of normal. This x squared tells me that it is a vertical parabola. So I've got a vertical parabola, okay? I've got a p-value of negative 2. I've got an h value of 4. A k is equal to 1. Now, to find the focus, I've got to use that p-value. So you were wondering, why are you actually taking this 4 out of there? Because I want to know what this value for p is, this minus 2. And if I take the h comma k minus p, well, k was a 1, so k 1 minus 2, 1 minus 2 gives me a negative 1. So my focus is at 4, negative 1. So let's look at this just for a second. I'm going to try to graph it one more time here. So my center was at what? It was at 4, 1, 2, 3, 4, minus 1. I'm sorry, 4, 1. There's my 4, comma 1. That's where my vertex is. And my focus is down here at 4, minus 1. That means it's going to do that. Okay? Cool. One more thing here. What direction does this one point? Well, it's x squared is squared. That tells me it's a vertical parabola. And since it's a positive x squared, it probably points up like that. Cool? So let's see if I can't work this out real quickly. So I'm going to get x squared plus 6x equals 4y minus 5. I'm looking for what I'm going to find to square this. So 6 divided by 2 is 3. 3 squared is 9. So plus 9 plus 9. And I'm going to get x plus 3 squared is equal to 4y plus 4. Well, that 4 is going to factor out of that, so I'm going to get x plus 3 squared is equal to 4 times, well, 4 times 1 times y plus 1. That means my vertex is going to be located at minus 3 minus 1. My value here for the p is equal to 1. That means it's going to open upward like this. So this point right here is at minus 3 minus 1. I can find the focus here, right? How did I find that focus? That meant I had to use this p value, right? And I take the k value and add it onto it. So I'm going to have my focus is going to be at minus 3, and I'm going to add 1 onto that, minus 3, 0. Cool? Cool. Now, typically at this point I'd be asking you how's your windshield. Since I haven't had you in here to ask questions, you probably have a few. That eccentricity probably confused you a little bit, and I'm not surprised about that. I need to make certain that you got that and you understand what's going on. I will include in when I send out this video a sheet that has all of the formulas that you will need for horizontal and vertical parabolas, ellipses, and hyperbolas. It doesn't include the circles because circles you can just use the ellipse one and make certain that you're A and B are the same value because you just multiply through it and you get the radius. Okay? Cool. Well, if you have any questions for me, do not hesitate to send me an email and let me know. I'm going to be testing today, but I should be available for the tutoring session tomorrow. If you don't see me, I couldn't get out of testing. So I'll try to leave that one on the schedule for you to get to it, though. I will talk to you next time.